Hello and welcome once again to this video lecture on examples of Grignard reagent. As we know, Grignard reagent is very important. It has a formula RMgX. So it belongs to a class of compound which is called the organometallic compound because it has a metal magnesium linkage. Now the advantage over here is the metals are electropositive in nature and therefore they would carry a plus charge, and the the organic substituent would be carrying a minus charge. So what type of reactions the Grignard reagent shows, let's understand with the help of these four examples. The first one, in this example we have CH3MgI methyl magnesium iodide. The ether is acting like a solvent. Ether is solvent in which the reaction takes place. So we have to see what will be the effect of addition of this molecule onto the cyclic ether compound. Now clearly, if we see the distribution of charge, magnesium, as I said, carries plus charge and methyl carries a minus charge. Now this methyl would be actually attacking the less sterically hindered carbon. Now this carbon is hindered because it has many neighbors. On the other hand, this carbon is sterically less hindered. So this methyl is actually going to attack at this carbon. So basically what is going to be formed as the result of addition would be a molecule like this. So we have something like this is OMgI, right? And this, let's say the CH2, and this is a CH3 adding over here. So this is the addition molecule. So basically the alkyl part is attacking a less sterically hindered site. So less sterically hindered site, right? Hindered site, as I say. Okay, now what happens when we hydrolyze it? So we need to see which bond is more fragile. So we can see the oxygen and the metal, this bond is very much fragile. So this is going to be hydrolyzed. What do we get? We get H over here and this is OH over here. So ultimately we end up getting this molecule which is OH and CH2 CH3. Now going to example number 2. In example number 2 we have this molecule and this is phenyl magnesium bromide in the copper salt. Now the copper salt is particularly useful when we have to do a 1,4 addition. Now 1,4 addition, why it will take place? Because we have C double bond O and conjugated to that we have a second double bond. So basically in this case, again you can see over here that this is plus and this is minus. So this pH minus is going to attack at this carbon, which is right the site of the 1,4 addition. The carbon cannot have 4 bonds, therefore this bond migrates. This pi electron delocalizes and this shifts again onto the oxygen. The positive part is going to attack at this. So clearly we can see it's an example of a 1,4 addition. So it's an example of a 1,4 addition reaction. Now clearly what happens because of this is something like this. So we have this molecule here and this pH, the phenyl group is attacking at this point, and then we have double bond and this is C. This molecule would be OMgBr and this is pH. So this is the molecule. Now what happens when we hydrolyze this? When we hydrolyze this, the most fragile bond is going to break. Again this is this bond which is going to break. So ultimately what we have something like this. This would be the phenyl which is coming from the Grignard reagent. This will be double bond. This is C, this is OH, and this is pH. Now clearly this is unstable because it's a phenolic component of the tautomer. Therefore it will tautomerize and revert back to the keto form. So ultimate answer for this, ultimately what we get is this molecule. This is benzene, this is C double bond O, and this is phenyl. So in this case Coming to example number 3, it's a very typical question where the addition of RMGX and X's occurs on an ester. How many molecules are involved? Let's see. Now clearly, in this question, we'll have to see again the same thing happens. Magnesium has plus and methyl has minus. It's going to add over here. So this molecule would be, it's a nucleophilic addition on the C double bond O. This is OMGBr. Now clearly we know that why MGBr is going over here, because it's minus and it's plus. And the CH3 adds onto this carbon. This is O, C2H5. Now what happens when you hydrolyze this? Now we have two bonds which are fragile. One is OMGBr and the second is this bond. Right? So we have H. So clearly this molecule that we get over here is CH3. This is carbon. We have two OH on the same carbon. Right? And the fourth substituent is methyl. Clearly having two hydroxyl group on carbon is not a good sign. It's not a stable sign. So basically we have removal of water molecule, and clearly what we get is acetone. Now, but what they have mentioned is that we have CH3 and GBr in excess. So clearly what we can do is we can add one more molecule of it followed by hydrolysis. So one more molecule is going to add of the Grignard reagent onto this, and ketones with Grignard reagent followed by hydrolysis get a tertiary alcohol following a similar kind of steps. So we have, this is OMGBr over here. This is CH3, this is CH3 on hydrolysis. What do we end up getting? We end up getting a tertiary alcohol, which is CH3 3 times, right, carbon OH. Coming back to the fourth example of a nucleophilic addition onto this molecule. So clearly again we have C double bond N, carbon is plus, nitrogen is minus, here it is plus, this is minus, nucleophilic addition. So clearly we have CH2, this carbon is here, we have a methyl group coming, triple bond becomes a double bond due to addition. This is NMGBr. Once we hydrolyze this is H2 and this is O over here. So clearly we can say ultimately what we end up getting is this molecule CH3, C double bond O, CH2 followed by double bond. So these were some examples on how the reaction happens in Grignard reagent. Hope you enjoyed this.